All right, chemists, today we're going to review how to do scientific notation. So in Google Classroom, you're going to find a note sheet that you can fill in as you're following along with the video. So the first step is to learn or remind ourselves how to convert from scientific notation to standard form. So when you're reading through and you see a power after the times 10, then you know you're in scientific notation. The exponent or power tells you how many places to move the decimal point. If the exponent is positive, you move the decimal point to the right. Remember that positive is going to be greater than 1. Positive is going to indicate to you big numbers. So if you want to think about it like money, like if you had a positive money situation, you would expect that you have a lot of money or greater than 1. If the exponent is negative, you move the decimal point to the left. So it'd be a negative money situation if you had less than $1. So here's some examples. This is a positive exponent, 3.24 times 10 to the fourth. Remember, these are just shorthand versions of numbers. So that is positive, so we expect a big number because it's positive to have lots. So I'm moving my decimal point over to the right, and my answer is 32,400. Now let's pay attention to the significant figures. Because 32,400 does not have a decimal point, that makes it 3 sig figs. So because 32,400 does not have a decimal point, that is 3 significant figures, just like 3.24 times 10 to the fourth. Remember that significant figures in scientific notation include all of the numbers in the coefficient. Our next example is 3.24 times 10 to the minus 4. Now, minus is going to be small numbers less than 1, so we're going to move it over to the left. And my answer is 0.000324. And again, note that the zeros that are leading before the 324 are placeholder zeros and they're not significant. Leading zeros are never significant. Next, let's review how to convert from standard form to scientific notation. So when you're in standard form and you want to get it to scientific notation, you're going to move the decimal point until the coefficient is greater than or equal to 1 and less than 10. So what that means is the coefficient or the number before the times sign has to be 1, but cannot be 10. So it is 1 to less than 10. Then we count how many place values you had to move the decimal point. So how many spots to the right or left did you have to move the decimal point? That is the exponent. If the number you started with in standard form was greater than 1, then the exponent is positive. If the number that you started with or the exponent was less than 1, then the exponent is negative. Remember that positive exponents mean big numbers. Negative exponent needs small numbers. Here's some example. This is a big number. So in order to move the decimal point, so it is 1 digit to the left of the decimal point, you're going to move it over between the 6 and the 5. That means we're moving it 4 spots. Because this number is greater than 1, that is a positive exponent. This is the other case where this is a small number, less than 1. So I'm going to move the decimal point over 4 places to between the 6 and 5 again. And this answer would be 6.54 times 10 to the minus 4. In class, I will show you how to let your calculator do the work for you. After you finish with the video, complete the practice worksheet.